Next, let's discuss the properties of the unit impulse function. The first is the time delay property. The unit impulse function discussed above takes its value at t equals 0. In fact, it's not necessary always to be t equals 0. Here, delta t minus t0 means the whole function shifts t0 to the right where t0 is a positive value. For this function, we can write its expression delta t minus t0 equals 0 when t doesn't equal t0. The integral of delta t minus t0 from negative infinity to positive infinity equals 1. Of course, similar to the previous expression, it can also be written as the integral of delta t minus t0 from t0 minus to t0 plus is 1. Besides the shift property, there's several other properties. For example, what will be when one function times delta t? We draw the graph of the function. Suppose the function is continuous at t equals 0. We draw the graph of delta t. When t doesn't equal 0, delta t is always 0. This is a multiplication expression, so its value equals 0 when t doesn't equal 0. The function is supposed to be continuous at t equals 0, so its value is f0. This expression equals f0 times delta t. This is an important expression, you must remember it. With this conclusion, we can substitute it into the integral of ft times delta t from negative infinity to positive infinity. F0 is a constant value, so it can be taken out of the integral. Then this equals F0. This is also an important conclusion. The discussion above is on delta t. With the shift property of the unit impulse function, we can also get that ft times delta t minus t0 equals ft0 times delta t minus t0. Similarly, by substituting this conclusion into the integral of ft times delta t minus t0 from negative infinity to positive infinity, we know it equals ft0. So at the end of this lecture, we will derive the relationship between the unit impulse function and the unit step function. These are the graphs of the two functions. For convenience, the moment when t equals 0 can be divided into 0 minus and 0 plus. Let's see, from the unit impulse function, what's the integral of it from negative infinity to the different upper limit? Firstly, we discuss the condition when t is less than 0 minus. In this condition, the integral is from negative infinity to t. Because t is less than 0 minus and delta equals 0 when t is not 0, so the result is 0. Secondly, t equals 0 plus. The integral of delta t from negative infinity to 0 plus equals the integral of delta t from 0 minus to 0 plus. According to the previous discussion, it equals 1. Thirdly, t is greater than 0 plus. The integral of delta t from negative infinity to t equals the integral of delta t from negative infinity to 0 plus the integral of delta t from 0 plus to t. This part is 1. When t is greater than 0 plus, delta t always equals 0, so this part is 0, so it equals 1. Let's observe the integral results. The integral of delta t when t is less than 0 minus is always 0. With t changes from 0 minus to 0 plus, the result changes from 0 to 1. When t is greater than 0 plus, the result is always 1. You can find this expression just equals the expression of the unit step function. When t is less than 0 minus, it's always 0. When t becomes 0 plus, it becomes 1. When t is greater than 0 plus, it's always 1. What does this mean? This means the integral of delta t from negative infinity to t equals epsilon t. To make this process conversely, we can get that the derivative of epsilon t equals delta t. Some of you may be confused about this point, because we've learned in calculus that the premise of a function with derivative is that it's a continuous function. Epsilon t is not continuous at this point. How can we discuss its derivative? We have two explanations. Firstly, from the aspect of mathematics, you may learn a course called the general function in the future. In the course, a discontinuous function may have its derivative. Secondly, in the physical world or the circuit world, we see there's a unit step from 0 minus to 0 plus. We've known that the derivative is used to express the rate of change. So the derivative of it means there's an infinite rate of change here. In other words, its derivative is the infinite value. Well, this is the end of this lecture.